Hey! Finally, I finished my power claw, and it was quite challenging. You know, I have two different types of designs. It's my swords that's powered by electric and have a lot of precessed parts and fully mechanical designs. And actually, I like it more because every time it's quite kind of breaking the limits of 3D printing. I'm studying new mechanism, and I like to think that it can be fully 3D printed by one material, by one printer, and also it can be scaled. For example, this claw is 80%. You can print it for your kids, or maybe you can print bigger one just for fun. And I like it, and I hope you like it too. Also, I know many of you don't like AI, and today it's my original voice. I don't use today AI voiceover. It's hard for me because I'm not native speaker, but leave in a comment what you think about it. Do you prefer AI voiceover with clear and good English, or my original voice, but maybe sometimes you will not understand me or with my not good pronunciation. But anyway, I very interested in your thoughts about it. And also it's first video in a new office, so background is quite plain, but I have plans to make some fancy LED lights and mount my swords or another stuff to the wall, so I think it will look nicer. So next I will explain how it works, show some printing settings and how to build it. So let's dive in. And now some explanation how it really works. So after making my Doom shield, where I use a bunch of ratchet and springs and also herringbone gear bearing, I decided to make something with my claw, and here I also use herringbone gear bearing, but now it's print in place. Why I use here this technique? Because when you print in place, you need to make some clearance between gears, and this causes some play. And if you will do in a big part like a shield, where is a big wheel, this plane will be too big, and it will be collided with the outer and inner shield. And here, so it's not quite big, and it's not colliding. It's colliding a little bit here, so that's why here is some round geometry. So it's just gliding here. And the main thing, it's with gears. I tried different gear ratio. Now here is gear ratio 12. So one rotation of this gear providing 12 rotation here. We need to big gear ratio to rotate with so faster, but bigger gear ratio make bigger resistance. So if you make like 20 gear ratio, it will be very hard to pull it. So I tried different, and 12 gear ratio looks very good because it rotates easily and save a lot of inertia here. So after you pull it, it's keep rotating. And actually you can make saw a little bit more heavy, like you make in field 50 on 100. It will be harder to pull, but it will be rotate for more time. So this mechanism works like a pump. So you push it and you pull energy in this saw. So as much you can faster pulling, you keep more energy in saw. Also, I add additional spring because now you have more friction here, so you need more tension here. So when you pull this rail rotate this gear. So with some claw, place it on this shaft with this gear, so it's rotated together. And this tiny rotation here, the fast movement of your hand, provide a lot of rotation here. And it's rotate for a long time. And it's funny. That's why I like to make fully 3D printed models, because it's like breaking the rules of 3D printing, breaking limits of 3D printing. So that's how it works. So let's move on. Now let's talk about printing settings. For most parts, 2 walls and 30% in fill, it's totally enough. It's good compromise between durability and lightweight. But some parts need some reinforcement, for example, this handle. Better to print with 4 walls and 30% in fill. The same for each pistons, also 4 walls, 30% in fill, and center claw, both parts, 4 walls and 30% in fill. When fill, I recommend grit or gigroid, but don't use recticleaner because it's not durable, it's not reliable. And also, all bolts must be printed with minimum 4 walls and 40% in fill, because it's high loaded. Also, for printed place saw binning, I have 2 options. One is standard and one with a bigger clearance between gears. It's good for scale down, or if you have some problem with flow ratio or maybe precision, it can also work well for you. Also, if you want to scale down, for example for 80%, you have to set up this parameter, XY contour compensation, and the value minus 0.1 millimeters. It's provide more clearance between parts, and it will be easy to assemble, because when I design it, I design some clearance between parts, but when you don't scale it, with clearance also don't scale it. And if you don't set up this parameter, it will be hard to assemble, hard to put in place some parts, and bolts will be screwed very tight. So it's definitely need for you. And if 100% also going very tight, you can also use this parameter. It's work very good. You can read about this parameter on this website. It's work like all surface will offset from original surface. So inner contour will be bigger and outer contour will be smaller. And also, to print this project, you need around 3.2 kg and 4 days of printing. So basically it's around 1 week of printing, but it's for 100%. For 80%, I think it will be around 2 kg or less. Okay, let's start. And start with the central claw. First, we install gear G1 on this shaft. Next, gear G6, we need to first install ratchet on it. You need to orient it clockwise, and also you can check it by putting it inside. This direction it's work, and if you flip it, it will not work. So this direction is correct. So insert it here. Next, insert gear G2. Next, G5. And gear G3 and G4 you need to insert together because it have strange geometry to print without supports. Like this. So it's G1, G2, G3, G4, G5, G6. And after this, you need to insert saw bearing. Make sure it's inserted on all depth. Also, you need to apply some silicone spray loop on all gears and shafts to decrease friction, and also on bearing. And after this final part, the second part of the claw. And finally screw the nut. Okay, next step, we need to assemble a big claw. So take claw gear, take bolt B2, insert it and screw it. You can use Daka wrench. Here also B2 bolts. If it's go too tight, you can rotate it back and forth. So making this movement, it will be easier to screw it inside. Repeat the same with second claw. Now we need front body and big claws, and also bolt B3. Don't tie too much because it must rotate freely. And again, and it's going too tight, you can try to rotate it back and forth, or you can print with XY compensation contour minus 0.1 millimeters. It definitely can help with it. And also, if you want to scale down this model, with contour compensation, minus 0.1 millimeter will help to assembly smaller model as well. Okay, check what it rotates. Also, if it rotates hard, you can use silicone spray lubricate. So just apply it here, or before you will screw bolt, you can apply on the bolt. Okay, next we need central gear shaft. Insert central claw inside and insert shaft inside. Oh, wrong way. From this side. Okay. Insert it here. It's have only one position. How you can insert it? Okay, secure it with a bolt V5. Okay. Now, if you want using metal spring instead of plastic spring, printed spring, you have to insert nuts inside nut position, nut slots here. You can use additional tools like screwdriver to push it inside. Sometimes it's not easy. So you can help with some additional tool like pliers to correct position and direction of the nut. Oh, my English so good. Sometimes it's just rotated in the slot, that's why it's going hard. Okay, done. And the same you need to make with the front body. Insert the nuts as well. Sometimes you just need to correct the nut. Also, you can use pliers for this, because two edges can move it more directly, more straight. Okay, done. For printed spring, it's much easier. And actually, in new version, I add additional spring on the other side, and it's work much better and provide very good tension. So it's work very good. Why I use metal spring? Metal spring keep tension for a long time, so it's more reliable. And when I sell physical copies, I assume that client can print by himself, so metal spring can survive for much more time. So now we can attach metal spring to the front body, because it will be easier to assembly after if we first attach spring to the front body. And the same on the other side. So now we need to attach handle to geared rail. We take bolt B2 and screw it. Only on one side. Like this. So this geometry in the front and this geometry, this angle to the bigger claw inside it, and we need to align these marks on gear. Actually, you can move it to make bigger claw a little bit asymmetry. So more natural, more orcish style. Okay, now second rail also align here. Bottom gear must be aligned in the same, like front, like in right position and left position must be the same. But big claw can be different, like this one. It's okay. Okay, now screw the second rail. Okay, it's must move easy. And now we can attach metal spring. We can open it a little bit to help it. Okay, now we can test it. And it's work. It's very loudy. And for the printed spring, it's a little bit easier. So again, first we need to attach handle. And now we need to insert the spring. It has a left and right spring, so you need to check it before. It have a little gap with this surface and this surface, so you need to check it first. So gap must be aligned to this surface. Also, here is locking geometry. Its locking geometry must be near this surface. So just press on it and it's locked here. Again, lock geometry. And the same on the other side. That's it. That's so easy and faster. Okay, now we need to insert hand holders in the main body. Just push it in the slots. And now we need to secure with these fixators. Also, now it has additional spring that prevent it to folding. So before it's folding by gravity, but now it will hold it. Just insert it and push on it. And now like this. After this, insert mega nut. Next, attach front body to main body, like this. So one bracket opposite center claw. B4 on upper side, opposite big claw, and B1 downside. And repeat the same on other side. Now place decorative cover on the front body and secure it with B2 screw. it's the same on other side. Okay. Now we need to attach piston to bracket holder. Just screw it inside. And attach it to the claw. Use B2 bolts for it. Also, don't screw all the way. It must rotate it. And on opposite side, the same. Here we need to use B4 bolts. Also, it must rotate. Now insert cylinder in piston and insert into the main body. Also we use here B4 bolts. Okay, almost done. Now exhaust pipe. So it just screw in like this and screw in main body. Okay. Now pipes. I make it separately for easy painting and printing without supports, because I liked printing without supports. I will show you just how to assemble it, but without glue. So insert first hose here. Here is flat geometry, and also here's a flat geometry. So it's inserted like this. After, here's also different connection geometry. So this one goes here, this one goes here, and this one goes here. Okay, like this. And on bottom. Size comparison 100% and 80%. If you enjoy this video and this project, don't forget to like it. Estelle files and physical copies will be available on my website. I will leave link in description. See you in next video with a new project.